So Integrated Math 3, this is the answers video for assignment 1.03 distributions. And I pushed back a lot of the due dates because it's just some complications and some new people coming into class. So this will really be due on Monday, February the 8th, all right? So that's a few days from when this is being recorded. So just go ahead and get it in by then. All right. Okay, so let's go ahead and do this. About 26 problems, but none of them are real long problems. So let's go ahead and get this done. So on the math portion of the SAT, the scores are roughly normally distributed. That means they have this bell-shaped curve with a mean of 500 and a standard deviation of 100, as seen here. So what that means is the mean is right here in the middle, underneath the highest point. That's the average. And a standard deviation is 100. So 500 to 600 is one standard deviation. Let me actually draw that down here. And if I draw a line down here, I can draw a line out here to 700 is two standard deviations. And all the way out here to 800, I should have said 700 if I didn't, to 700, from 5 to 700. And then another, from 500 to 800 is three standard deviations. And then that's true going back in the other direction. So that's one standard deviation. That's two standard deviations. And finally, this one all the way out here is three standard deviations. That's all the way from there to there. Okay, so plus or minus one standard deviation, plus or minus two, plus or minus three. If you're within plus or minus one, it's 68% of the values. So it helps to break that down into cut that in half. So we get that. Put this one here. Okay, so this is going to be 34 and this is going to be 34%. That's one standard deviation. That's this distance that I drew down here. That's 34%, that's 34%. So that's the 68 here cut in half. For this one, 95 cut in half comes out to be 47.5. So right here, from here to here, that's 47.5%. And from here over to here, that's 47.5%. Add those together, you get the 95% between those two lines. And then this one is 99.5. So half of that would be 49.85% on this side and 49.85% on that side. And then outside is a very small little bit amount. A lot of times we just say that three standard deviations is 100% of the data. Well, that would make this actually to be 50% of this 50%. It's just a little bit less than that. But okay, so now we can go ahead and answer some questions. What percentage of SAT scores are above 400? All right, so and by the way, this amount we should put is this amount is 0.15 here, and this amount right here is 0.15 there. So we'll be accurate. So this is 49.85 to here, and then this last little amount to the very end of the curve is 0.15. That would give you 50%. So 50% are below the mean, 50% are above the mean. Okay, so what percentage of SAT scores are above 400? So here's 400, and you want everything to the right of that. Okay, so from here over to here, to the very end. Well, first of all, from the mean all the way to the right side of the curve is 50%. Okay, so I'm going to just sketch this real quickly here. And here's the mean at 500. So, and here's one standard deviation below the mean is 400. That's what we're interested in. So what's that difference between 4 and 500? It's this 34% right there. There's 500, there's 400 right there. So that's 34%. So this is 34%. And everything over here on the right side of the curve from the mean all the way to the end is 50%. It's half the values. It's that 49.85 plus that 0.15 there. Okay, that goes from here all the way to the side. So if you add that together, you get 34 plus 50 equals 84%. Okay, and that's the answer to that. Either show a calculation or write it out as a complete sentence answer. I think in anyway, I think in class I did it as a complete sentence answer. What percentage of SAT scores are above 500? Well, that's easy. That's easier than this one. It's half. 500 is the mean, so half of them are to the right, 50%. Half of them are to the left, 50%. So that's just this shaded portion that I did right here is 50%, okay? So in this case, I'll do it in a complete sentence answer. 50% are above 500, and 50% are below, if they had asked that. That's the answer. That's all you need to learn. Okay, number 3. What percentage of SAT scores are below 700? All right, so here's 700. 700 is 2 standard deviations from the mean. So what we're looking for is everything to the left of 700. So it's from 700 down to 500, and then from 500 all the way down to this side of the curve. So let's do 700 to 500 first. That would be this right here, 47.5. That's that distance. That's 2 standard deviations. So it's 47.5. And then, so that takes us from 700 down to 500, and then from 500 down here, that's half the scores. That's 50%. Okay, it's in the entire, this half of the curve right there. So that's going to be 50%. Okay, and that's going to equal 97.5%, or below 700. Okay, all right. Okay, between what 2 values do approximately 95% of the scores lie? All right, so we come back here. So 95%, we can look at this number right here. 95% of the scores are within plus and minus 1 but 95% of the scores are between plus and minus 2 standard deviations of the mean. That's this. So what is that? It's between 300 and 700. Okay, so that's the answer to number 4. Okay. What is the score of a person who scores higher than 84% of the people who take the SAT? Okay, so where's 84%? So let's start at this side, and let's just count percentages until we get up to 84%. Well, 50% is this entire side of the curve. So there's 50%, but you did better than not only 50%, you did better than 84. So if we come over 1 standard deviation from the mean, that's 34%. So if we add the 50% from the left side to the mean, and then 34 more percent, which is to the right, that 34%, that gives you 84%. So that would mean, what was the question? The question is what score? That would be 600. 600 is better than 84% of the scores. Okay, let me say that again. When you start here, you go to the mean. That's 50% of the scores right there. So it's more than that. We got to keep going. And then we go to the first standard deviation. That's another 34%. So it's 50% plus 34%. That's 84%. So at 1 standard deviation above the mean, 600, that's better than 84% of the scores. Okay, and that's the answer right there. All right, given a normal distribution with a mean of 175 and a standard deviation of 37, they want you to draw a normal curve. Okay, so here's what we're going to do. Did this in class. Draw it very low and wide so you have a lot of space to write. So I'm going to start it way down here. I'm going to draw it way across here. And I'm just going to freehand the normal distribution, try to do it as neatly as possible. And I'm going to draw it very wide so I have a lot of space to write in down there. So there's the mean. So it says the mean is 175. So there's 175. One standard deviation, and these should all be about the same distance. You don't have to really measure it. If I had a better ruler, I could do it though. And I don't know. So I'm just going to go, I'm just going to go from here. Yeah, I'll use inches here. Okay, here we'll say that's one standard deviation. 2, that's not really going to be very good for my curve. I'm going to say that's 1, that's 2, and that's 3. Okay, I'm just eyeballing it here. Not really measuring. Okay, so this is plus 1 standard deviation. 175 plus 37 is 212. Again, why is that? Because there's 37 to get to 1 standard deviation above. Now to get to 2 standard deviations, let's write that. That's 1 SD. To get to 2 standard deviations, you add another 37, and that's going to get you up to 249. And to get to 3 standard deviations, you do another 37, so that's 4970, and that's 286. Let me just check my math. 37, 12, 22, 32, 42, 49, 49, 59, 69, 79, 86. Okay, yeah. Now in the other direction, I'll try to make this about the same distance. Do the best I can. But I didn't quite get it. There. There. Right there. Okay, so this is 1 standard deviation below the mean. So it's going to be 175 minus 37. So that's going to be 138. 2 standard deviations is going to be 138 minus another 37 is 101. And 3 standard deviations is going to be 101 minus 37 is going to be 64. Okay, and then this is the mean mu. Alright, so there you've done what they asked you to do. And we labeled the 1, 2, and 3 standard deviations. What percent of values are within 138 to 212? So 138 is minus 1 standard deviation. 212 is plus 1 standard deviation. And going back to the graph on the previous page, if you're within 1 standard deviation, you have 68% of the values. Okay, so that's 68%. I'd like you to write a complete sentence, but just for the sake of time, I'm just going to put down the number. You put down the number alone and not a sentence, and I will zap you a few points, okay? So please don't do that. Okay, same thing here. Between 101, there's 101, and there's 249. What percentage? Okay, go back and look at that same graph. I'm going to leave this for you to do. And number 9, what percentage are between 64 and 286? That's 3 standard deviations. Okay, so I'm going to leave this one also for you to do. All right. What percent of the values are outside 138 and 212? Well, we said 68% are between those two numbers. That was the question number 7. Since there's 100% of the values under the curve, you take 100% minus 68%, and you get 32%. So 32% are outside 138 to 212. I'll write 2. That's not minus 212. It's 2 212. Okay, so that's the answer for this one. Okay, 11 and 12 are similar, except they relate to question 8 and question 9. What percent are outside of this? What percent are outside of that? So those are going to be U problems. All right. Okay, we're halfway done with the assignment. It's not taking that long. Okay, use the following for questions 13 through 18. Give an approximate normal distribution with a mean of 159 and a standard deviation of 17. So we're going to do the same thing we did on the last one. We're going to draw a kind of a low curve so we have a lot of space to write. And let me just show you. You really don't need to draw the curve. You know it looks like a bell curve. So we're just going to say there's the mean. Now I don't have to worry about drawing a sloppy curve. So this is the mean, mu equals 159. And let me see what I got here as far as inches. Yeah, 3 inches looks good. This way, 3 inches. I'm trying to just be sure I make it kind of neat. I tell you what, I'm going to make my line a little longer. And in this direction also. Okay, so I'm going to just say 1 inch is going to be 1 standard deviation, 2 inches is 2 standard deviations, 3 inches is 3 standard deviations. Okay, in the other direction, same thing, 1 inch. Again, I'm just picking those distances because they fit. Okay, so this is 150, it's 159 actually. Plus 17 is 69, that's 176. That's 1 standard deviation. Another 17 gets you to 86,193. That's 2 standard deviations. And another 17 gets you to 210, and that's 3 standard deviations. Again, 159 and 17, and that's where I got those numbers from. Now 159 minus 17 is 4942. It's 142. That's 1 standard deviation below. Minus another 17 is 125. That's 2 standard deviations. And minus another 17 is going to be 108. And that's 3 standard deviations there. Okay, you don't have to draw the curve. All right, so there we did it. If you want, you can just go ahead and makes you happy. Just do that. Okay, what percent of the values are within 142 to 176? Okay, that's within 1 standard deviation, so that's going to be 64%, 68% between these two right here. Okay, right in that line right there. What percent of the values are between 125 and 193? That's plus or minus 2 standard deviations right there. Okay, you should know how to do that by now. I'm going to leave that for you. It's the same. I'll just tell you it's 95%, plus or minus 2. Again, just go back to this as your reference sheet. That right there, 2 standard deviations is 95%. Okay? And the third one, I'm not going to tell you. That's a U problem. So this one I'll give it to you. I gave it to you. This one's between 125. Oh, this one's, yeah. Oh, sorry. This is the 95%. And this last one, let's see. Okay, well, anyway, there's that. So this wasn't a U problem. So 142 is 1 standard deviation. That's 68%. Okay, I gave them to you. Write a complete sentence. Okay. What interval contains 99.7? That's 3 standard deviations. Again, you kind of learn to recognize these numbers. So that would be, there's 3 standard deviations, 108 to 210. Plus or minus 3 standard deviations. What percent of the values are above 176? Okay, so let's do that one. So 176. So here's the mean. 50% of the values are above the mean. Okay, that's all you have to remember. It's always 50% is above the mean. And 34%, so I'm just going to say up here, I'll write that up here. This is 50% all the way to the end of the curve. So 50% are above 159. But they don't want to know 159. They want to know 176. So what percent are in this right here? And that's half of the 68. That's 34% are between here and here. So if I take this 50%, the entire right side of the curve, and subtract this piece of it, that 34%, that'll tell me how many are from 176 to the end. Okay, again, all the way minus this gives you just this part right here. That's 76. So that's 50% minus 34% is going to give you 16%. So write that out in a sentence or show the calculation. 50% to the right minus 34% within one standard deviation. That would be from 159 to 176, and that's going to equal 16%. Okay, and that's this distance right here. That's from here all the way to the end. 16%. That's a percent sign. 16%. Okay? All right. Keep going. 18. What percent of values are below 125? So we come back here and we realize again that 50% of the values are to the left of the mean. That's 50%. Okay, and how many are between the mean and 125? Well, that's 2 standard deviations. So if we go back here, from the mean to 2 standard deviations is 47.5 from here to here. So if we want to know what percent are below this, they're over here. We take this entire distance here, that's 50%, minus this distance, 2 standard deviations, is 47.5%, and that'll give us this distance right here, which is what we want to know, below 125. So you simply come here and you say 50% of the curve to the left minus 47.5%, which is that's 2 standard deviations to the left, is going to equal 2.5%. Are below, and I do want you to write this out and explain it, not just write a number, are below 125. So 2.5% of the scores, that's really the answer, are below 125, are from here down to there. Okay, let's keep going. Okay, and then the last six problems. Okay, I did a few of these in class. So this one just adds one additional step. It's really not even any harder. So what I'm going to do is I am going to draw, again, the curve without drawing the curve. So we have the incubation time of Rhode Island red chicks is normally distributed with a mean of 21 days and a standard deviation of 1 day. So I'm going to come up here and I'm going to draw a 6-inch line here. Right there. And the mean is right in the middle at 3 inches. So 1 standard deviation is at 4 inches, 2 standard deviations is at 5, and 3 is at 6. They're equally spaced. Even though they don't hold equal percentages, they're equally spaced. That's because the curve is a curve. Okay, so there's 1 standard deviation, 2 standard deviations, 3 standard deviations. So there's the mean, and that equals 21. Then that means 1 standard deviation is 1 day, so this is going to be 22 is 1 SD. 23 is 2 SD. 24 is 3 SD. Okay, and going in the other direction, 21 minus 1 is 20. 1 SD, 19, 2 SD, 18, 3 SD. I'll just write that here. Okay, and then remember, a little bit of the curve is outside of 3 SD in both sides there, okay? A little bit. Okay, so if 1,000 eggs are being incubated, how many chicks do we expect to hatch in 19 to 23 days? So 19 to 23 is plus or minus 2 standard deviations. And we know that plus or minus 2 standard deviations is 47.5, 47.5, or right here it shows it is 95%. 95%. So 95% between 19 and 23 days. But that's not what they asked. They want to know how many. So what's 95%? So first you got to understand what percent means. Let's go over here and figure it out. 95% means, the word percent means per 100. It means 95 per 100, 95 over 100. So now you have a little division problem there. So you come to your calculator, and I do 95 divided by 100, and it gives me 0.95. If you're going to deal with percentages, you have to convert them to decimals like that. So you can't say 95%. You've got to say 0.95. Okay, 0.95. So now we can multiply 1,000 eggs times 0.95. And traditionally you put a 0 in front of the decimal point if there's no other number there. So I have 0.95 already in my calculator, so I'm going to multiply that by times the answer, 0.95 times 1,000, and that gives us 950. So that's your answer, 950 eggs. So it's pretty much the same as the earlier problems, except you add that last step. One simple way people do the percentage thing is they say 95%, there's a decimal right there. You don't see it, but it's right there. If you had to put a decimal, it would be right after the 5. So you move the decimal over 1, 2 places, and that gives you 0.95. If you had 4%, just to pick an example, you move the decimal over 2 places, right there, but there's nothing there, so you put a 0 in there. So that would be 0.04. Okay, so 4% is 0.04, 95% is 0.95. Okay, let's keep going. 1,000 eggs are being incubated. How many chicks do we expect to hatch in 21 days or fewer? Okay, so 21 days is the mean. That means that 50%, half of them, are going to be on the left side of the mean, right there, this whole area. So 50% are going to hatch in 21 days or fewer. And so we take our 50% and we'll do it the shortcut way. You just put the decimal there at the end, move it over 2 places, and that equals 0.50. And so you multiply 1,000, you probably do this in your head, times 0.50, and that gives you 500. It's half the eggs. Half of 1,000 is 500. Okay, so either show your calculation or write a complete sentence answer, okay? 500 eggs. Okay, if 1,000 eggs are being incubated, how many chicks do we expect to hatch in 19 days or fewer? Okay, so 19 days is way out here. It's 2 standard deviations, so we expect everything on this side of 19. That's 19 days or fewer. 19 days, 18 days, and then everything less than 18 days. So it's that. So we know that this is 50% from the mean all the way to this side of the curve. And we know that this in here is 2 standard deviations. Again, we come back to this. That's 47.5 is 2 standard deviations to the left of the mean. Okay, so this is 47.5. So to figure out the percent, it's the entire side minus this part of it. 47.5 will give us this part right here. Okay, we already did a problem similar to that earlier. So 50% minus 47.5 equals 2.5%. Now we're going to come over here and write 2.5%. We're going to do our little decimal trick. It's 1, 2 places, and then you got to fill this in with a 0. So that gives us 0.025. And now again, they want to know how many eggs. That's 1,000 times 0.025. And grab a calculator. So it's, I'll just do it again formally. It's 2.5 divided by 100 equals, there's the 0.025 we just came up with, and that's times 1,000. And that gives us 25 eggs. Okay. Less than 19 days. So that's your final answer right there. Okay, keep rolling. Okay, if 1,000 eggs are being incubated, how many chicks do we expect to hatch in 18 to 24 days? Okay, so 18 to 24 days is plus, well, this is plus or minus 3 standard deviations. 18 is minus 3 standard deviations. 24 is plus 3 standard deviations. And the number, the percentage within that is 99. I think I said 99.5 by mistake. No, it's 99.7. 99.7 is that percent. So let's just do our little percent shortcut. 99.7 are going to be between those two numbers of days. Okay, I'm going to move the decimal over 2 places. So that equals 0.997. So now we have to multiply that by 1,000. Okay, and if you do that on your calculator, you get 997. Almost all of them. Only 3 eggs are either before 18 days or after 24 days. Okay, there you go. Okay, keep going. See, these problems aren't really long. You just have to know what you're doing. 23. Okay, there we go. Will be expected to hatch in 22 days or more. So come on back here. So there's 21. There's 22. So they want to know more than 22 days. 22 or more. That's this area over here. Greater than 22. So again, half of the curve is above the mean. That's 50%. And this portion in here up to 22 days is 1 standard deviation. And we've seen many times before that's 34%. So if we want to know this, we take this entire 50% minus this little piece of it, 34%, and that gives us 50% minus 34% equals 16%. Okay, so this little piece of it up here, all the way to the end, not just to there, is 16%. So that's what percent it would be. So we use our decimal trick. We move the decimal over 2 places to the left. That's 0.16. I'll write 0.16 times 1,000. And that's going to equal 160. And that's after 22 days. Or more than 22 days. It'll take more than 22 days for them to hatch. Oops, should have had that. Okay, all that. All right, that's your answer for that. All right, okay, between 18 and 21 days. So let's come back here. Okay, so between 18 and 21 days is exactly 3 standard deviations. Now that's not 50%. 50% includes this little part outside of 3 standard deviations. That is this number that we came up with a long time ago. 49.85 is minus 1 standard deviation on this side. That, in this case, is 3 standard deviations to the mean. Mean to 3 standard deviations. So that's going to be 40 49.85. So I'm going to come here. So 49.85 between are going to be hatched between so we come down here 49.85 and we're going to move our decimal over 2 places right in front of the 4, so it's going to be 0.4985 times 1,000. Okay, and what that's going to give us is 498.5 eggs. Now, you can't have half an egg. So you would say, well, since you're not going to get all the way to 499, you only have 498 and a half, you're just going to say 498. If you left the 0.5, I don't really care. So let's just say, though, 498 eggs between. Okay, there's your answer, okay? If you left the 5 on, I don't care. Okay, next, between 19 and 24 days. Okay, so we come back here. 19 is minus, okay, so now they're getting a little tricky here. 19 is minus 2 standard deviations, and 24 is plus 3 standard deviations. All right, so 3 standard deviations, it's not the 50%. So I'm going to just change this since we're not using this anymore. I'm going to erase the 50%. It's not going all the way to the end of the curve. It's going to 3 standard deviations. And we see that that is also in that direction, 3 standard deviations is 49.85%. So this is 49.85% from the mean to 3 standard deviations. And now going backwards from the mean to 19 days, that's what they asked us, that's only 2 standard deviations. So you're going to take the 47.5 here, this number from the mean to minus 2, and add it to the 49.85, which is from the mean to plus 3, because that's what they asked, from 19 to 24. So let's go do that. So here it's 47.5. And this one is 49.85. Okay, and we're just going to add that. We get a 5 and we get a 3 for 13, 16, 17. Carry the 1 is 9, 97.35%. So now we can write that number down. Move the decimal over 2 places to there in front of the 9. So it's going to be 1,000 times 0.9735. And you multiply that, you get 973.5 eggs. Again, you could say you didn't quite make it to 974, so you can't have a half an egg, so it's 973. So 973. Between, what was it, 19 and 24. 19 and 24. Okay, and why don't we just finish this up? Okay, let's do the last one together. Okay, and don't forget I did ask you to do this assignment, to watch this video, very short video. Not real short, I'm sorry. It's maybe 7 minutes, I think. It's not that long. And write 5 to 7 sentences. So I'm really going to be looking for that, okay? Don't blow that problem off. That's a big part of the score on this assignment. Okay, 18 days or more. So here we go. 18 days is minus 3 standard deviations. Not all the way to the end of the curve. It's minus 3. So again, I'm going to erase this 50%. It goes from the mean to there. And that is this number, 49.85. Okay, so that's 49.85 from the mean to 3 standard deviations. It said 18 days or more. So you want everything from 18 days all the way to this side of the curve way over here. It's almost everything, but not quite. Okay, so from 18 to the mean rather is 49.85, and then from the mean to the far right-hand side of the curve, that's half the values. That's 50%. So we're simply going to add 50 and 49.85%, and that is going to give us, just write it over here, 99.85%. Move the decimal over 2 places, and that's going to give us 0.9985 times 1,000. Multiply that, and over here I'll write the answer. It's going to be 998.5, but you can't have a half an egg, so it's going to be 998 in more than 18 days. Okay, that's your final answer for that, okay? So go ahead and do those. Be sure you understand them. Watch the video. 5 to 7 sentences. You give me less than 5 sentences, I'm going to give you less than a full score. Okay, when I say 5 to 7, but I don't want you to write a book either, okay? So don't give me, a whole page. 5 to 7 sentences is really what I'm looking for, okay? So just take maybe a little planning to cover what they talk about in this one. By the way, I'm interested in the Wahoo's example, not the rainfall example she gives at the beginning. So talk about the Wahoos. Don't worry about the box plot. We didn't study that. But just talk about standard deviation, okay, and how they use standard deviation. Okay, that's it. I will see you in class, and you all have I won't see you till Monday, so have a great day. So get assignments 1.01, 1.02, 1.03 done by Monday, February the 8th. I'll be happy. And we'll kind of keep a more regular pace going forward in the future. Okay? Have a good day. Have a good weekend.